So today we're going to solve a kind of problem that involves both momentum and something else. So in this case, projectile motion. So here's what we have. We have a bullet flying along. It's moving with an initial velocity v naught. So I will call this v naught. It smacks into another block and the two hit and stick. And then together the pair fall off the table and land on the floor. Okay? And so what we want to know is how far horizontally does the pair of objects, so the bullet and the block of wood, how far do they travel horizontally after the collision? Okay? So this is going to involve two steps. And when you solve problems like this, when you solve any problem, when you apply a principle in physics, you've got to state the principle you're going to apply. Okay? So I'm going to start off by figuring out what happens during the collision. Because the bullet's going to smack into the block of wood, become embedded, and the two of them are going to start moving to the right. As they begin to move to the right, they become a projectile. So our first problem is to figure out how fast is this combination moving after the collision. Okay, so things we are given, we're given h. So I'll just write over here things that are given. This is like our variable list. We're given h. We are given the initial velocity of the bullet, m0. We are given the masses m and capital M. And what we're trying to find, the unknown, is this distance delta x that it travels horizontally. Okay? All right, so the first thing we're going to do is we're going to apply the conservation of momentum principle to figure out how fast the combination is going after the collision. Okay? So I'm going to apply the principle that the force times the time on the system equals the change in momentum of the system. And because there is no external force, the momentum of the system, P final, must equal the initial momentum, P initial. Okay? And this is for the collision. Okay? So I should put, I'm applying this to the system. All right? So the final momentum, these two blocks are stuck together. So the final momentum is going to be little m plus big M times the final velocity. And that's got to equal the initial momentum. So the initial momentum is going to be the mass of the bullet times its velocity. So that's m times v naught. And the big mass is stationary. It's not moving, so it contributes no momentum. Okay? So here's what we have. And so I can find the final velocity of the pair after the collision. All right? So v final is going to equal m v naught over little m plus big M. That's the velocity of the pair as they, after the collision, as they leave the table. Okay? So that is for the momentum, the collision. All right? And I might even put on there for the collision. All right? Now, after the collision, we have these two guys moving sideways, and they fall off the table, and they become a projectile. So here's the thing that's important to realize. The final velocity for the projectile becomes the initial horizontal velocity. The final velocity for the collision becomes the initial horizontal velocity for the projectile. Okay? So the next thing I'm going to do is I'm going to solve a projectile problem. So this is a projectile problem. And the key thing here is that the velocity for the projectile in the x direction initial equals the final velocity for the collision. So what I'm doing here is I'm showing you the connection between the two problems. We've got a collision, momentum is conserved, we have a projectile, and this is the connection. Okay? So you guys know enough about projectile motion to solve these kinds of problems, I think. Because it's horizontally launched, because it's moving horizontally, the velocity in the y direction initially is 0. Okay? So the first thing we're going to do for the projectile is we're going to try to find the time that it's in the air. So I'm going to go, this is step 1. This is step 2. So the third thing I want to do is find the time it's in the air. And that's determined by the y problem. So I know that delta y equals velocity in the y direction initial times the time plus 1/2 the acceleration in the y direction times the time squared. Because it's horizontally launched, the velocity in the y direction is initially 0. Delta y is negative h, so I get negative h because it goes from here to here. That's a distance of negative h, equals 1/2 of the acceleration, which is negative g, times t squared. And I can solve this for t, the time that it's in the air. It's going to be 2 times h over g square root. Okay, that's how long it's in the air. And then the fourth step is to solve the horizontal problem. So I want to find delta x, which equals the velocity in the x direction initial times the time, plus 1/2 the acceleration in the x times time squared. There is no acceleration in the x direction, and so the distance it goes, delta x, equals the initial velocity in the x direction times the time. And I can put in what I have for that. That means that delta x equals the velocity initial in the x direction is the final velocity for the collision. So that's m v0 over m plus m times the time, which is 2h over g square root. Okay? So what I've done is I've put two problems together, a collision problem and a projectile problem, and I've derived an expression in terms of the things that were given for the distance it will go horizontally. Okay? Now, once you do that, you could then use it in reverse. For example, if you knew delta x, you could work out the height. How high is the table if you know how far it goes? Or maybe you don't know the initial velocity. You could solve this for the initial velocity. But we developed this expression by putting together two problems. And so what you're going to need to do for this problem set is make a clear diagram and label it. When you apply a principle, tell me the principle you apply and try to solve it algebraically. And then, if there's more than one problem, like a collision and then a projectile, you've got to explicitly link the two problems. Okay, so I got to see that in your solution. The velocity for the projectile initially in the x direction is the final velocity for the collision. And then you can work out the rest. Okay, so you're going to do a set of problems. There's only 6 problems, but each of them requires you to use momentum and something else. All right? So work out an algebraic expression, and then to check and see if this is right, you can use the numbers I give you to plug it in and see if you get the right answer. Okay? So that's the job for today. 6 problems, problem set 6.5, and it is online waiting for you.